today we are going to continue our chemistry's chapter 2, different types of chemical reactions. We were going through it. Today we are going to see what do we mean by decomposition reaction. So decomposition, as we already know, one thing gets divided into or breaks up into different other things. In chemical reactions, a compound, it breaks up into elements or simpler compounds such that these do not combine back to form original compound. Such a reaction is called decomposition reaction. So what is decomposition reaction? In decomposition reaction, a compound splits into or breaks down into elements or simpler compounds. It may be an element or little simple compounds. And these simple compounds or elements do not join back together or recombine together to form the original compound. Such reactions are called decomposition reaction. So this decomposition may occur in the presence of heat, light, or by passing electricity. Okay, so these are needed so that decomposition reaction may occur. It may be heat, it may be light, or it may be the passing of electricity. So in a decomposition reaction, we have to see what happens in different types of decomposition reaction. In a decomposition reaction, the first one, a compound breaks into two or more elements. Okay, a compound breaks into two or more elements, not compounds. For example, the compound mercuric oxide, when heated, decomposes to form two elements. One is mercury, Hg, and oxygen. So mercuric oxide, HgO, when we heat it, it breaks down or it decomposes into mercury and oxygen. This is the first thing that may happen in a decomposition reaction. And in second type, a compound may break up to form sometimes both elements and compounds. It may become elements and one part may be a compound, simple compound. So example of such a reaction is the compound potassium nitrate. Potassium nitrate on heating becomes or decomposes to produce potassium nitrite and an element oxygen. Oxygen is an element, whereas potassium nitrite is a compound. So that is the second type. 2KNO3, when heated, heat, it is sometimes represented by a triangle like this, may become potassium nitrite. Potassium nitrate on heating decomposes to form a compound called potassium nitrite, 2KNO2, and an element oxygen. So this is the second type. In third type, a compound can break up to form two or more new compounds. A compound may break into two new compounds. Simpler ones may be simpler ones to new compounds, not elements, isn't it? So a compound may break up into two or more new compounds. For example, the compound calcium carbonate on strong heating decomposes to form two compounds. One is calcium oxide and the other one is sulfur trioxide. Both are compounds, isn't it? Calcium carbonate, CaCO3, when we heat it up to 1000 degrees Celsius, we get calcium oxide and carbon dioxide. Both of these are simple compounds, isn't it? So a compound may become simpler compounds. So these three are the different things that may happen when substances undergo decomposition reaction. And decomposition reaction which is caused due to heat is known as thermal decomposition, where decomposition reaction that is brought about by heat is known as thermal decomposition. By giving heat, the substance or the compound splits or breaks down, then such a reaction is known as thermal decomposition reaction. Now we are going to see thermal decomposition of metal compounds. And you might have studied what is reactivity. There is a list of metals and hydrogen which forms the reactivity series. You have heard about it. So reactivity series gives a list of all the metals starting from the highly reactive metal to the least reactive metal. Such an arrangement is known as the reactivity series, and decomposition of compounds of metals are based on their reactivity or based on the position of these metals in the reactivity series. So compounds of reactive metals are stable. They are stable. They do not decompose easily, while less reactive metal compounds decompose readily. They undergo decomposition reactions easily. So based on the reactivity series or the position in the reactivity series, the decomposition reaction proceeds. So we will see one by one. This is the highly reactive metal, potassium, then sodium. Okay, so metal like potassium and sodium, they form metal hydroxide. They are stable to heat. They will not decompose easily. Isn't it? Metal hydroxides are stable to heat. They will not easily form other compounds. But later when we come down the reactivity series, metals like calcium, magnesium, aluminium, zinc, iron, lead, copper, these decompose on heating to form metal oxides. Please remember, these metals after sodium in the reactivity series, when we heat it, they readily forms metal oxide and water vapor. Calcium hydroxide, when we heat, it becomes calcium oxide plus water. Zinc hydroxide, on heating, it becomes zinc oxide and water. Like that we get metal oxide and water vapor. Then in the bottommost part of the reactivity series, we have the least reactive metals. Okay, least reactive metals like silver, gold, all of them, they gives metal, oxygen and water vapor. From, you can see here, AgOH is silver hydroxide. When silver hydroxide undergoes decomposition reaction, it gives silver, the metal silver, oxygen and water vapor. Okay, water vapor. So that is metal hydroxide. Next group is metal carbonates. The metal carbonates of potassium and sodium, we know that they are highly reactive metals. We have just saw that highly reactive metals form stable compounds. They are stable to heat and they are soluble in water. Whereas carbonates, calcium carbonate, magnesium carbonate, aluminum carbonate, all of these decompose on heating with decreasing vigor to form metal oxide and carbon dioxide. Decreasing vigor means when we come down, the reaction is not that fast or not that serious, isn't it? And when we come back to here, Ag, mercury and silver, they forms the metal, oxygen and carbon dioxide, same like metal hydroxide. They form metals, oxygen, and here it is carbon dioxide, but in metal hydroxide it is water vapor. Okay, so that is the difference. Third, metal bicarbonates, mainly metal hydrogen carbonate. So sodium hydrogen carbonate or metal hydrogen carbonate decomposes to give metal carbonate, water vapor and carbon dioxide. For example, sodium hydrogen carbonate, when we heat it, it gives sodium carbonate, water vapor and carbon dioxide. Calcium hydrogen carbonate will give us calcium carbonate, water vapor and carbon dioxide. Magnesium hydrogen carbonate or magnesium bicarbonate gives us magnesium carbonate, water vapor and carbon dioxide. Just remember it. Okay. Now metal nitrates, potassium nitrate, sodium nitrate, on heating they melt and decompose to give metal nitrite and oxygen. Remember this, metal nitrites. Nitrates will decompose to give metal nitrites, N-I-T-R-I-T-E-S, nitrites. Nitrate becomes nitrites and oxygen. Whereas the intermediate metals, when they decompose on heating, they will give us metal oxide, nitrogen dioxide and oxygen. These are the highly reactive, these are the medium reactive elements. So these medium reactive or moderately reactive elements or metals, on heating they decompose to form the metal oxide, nitrogen dioxide and oxygen. And the least reactive ones, mercury and silver, they forms metal, nitrogen dioxide and oxygen. Metal, nitrogen dioxide and oxygen. And lastly, in our body also decomposition reaction occurs. You know what happens when we eat the food, what happens during digestion, all these you have already studied in biology. So decomposition reaction takes place in our body. Best example is digestion of our food. It is an example of decomposition reaction. We know that our food contains starch, and with the help of chemicals, which are the enzymes produced in our different organs, these break down the compound food into simpler ones. So starch breakdowns with the help of enzymes to give glucose, and this glucose again undergoes oxidation reactions to form carbon dioxide, water and energy. Okay, so that is what happens in our body. So complex food is broken down into simple food, then only our body is able to absorb it and give us energy to do our work. This is what happens in our body. So decomposition also occurs inside our body in digestion of food. Remember, another type of reaction is reversible reaction. From the name itself we can see that reversible reaction means, we have seen that a chemical reaction, we write the reactants on the left side of the arrow, isn't it? Reactants on the right side, we write the products. So here you can see that only one headed arrow, isn't it? So reactants will become products. But in certain chemical reactions, this products again becomes reactants. Products again become reactants. So such a reaction in which a reaction may proceed in both forward and backward direction. Forward means reactants to products, backward means products to reactants, isn't it? So reactants become products as well as products again becomes reactants. Such a reaction is called reversible reaction. So what is reversible reaction? A reversible reaction refers to a chemical reaction that proceeds in both forward and backward directions, resulting in the conversion of reactants to product and vice versa. Here is an example. You can see that a reversible reaction is represented like this, not full arrow, half partial arrow in both the direction, forward as well as reverse direction. Copper sulfate 5H2 is the water of crystallization. It undergoes to become copper sulfate and water. Again this copper sulfate and water will react together to give back copper sulfate dot 5H2O. So this is how we represent a reversible reaction. To show that the reaction is reversible, we put the sign, this one, in between the reactants and the products. If you find this sign, it means that the reaction is reversible. Okay, one more type we have to study here. A simultaneous reversible decomposition reaction brought about only by heat is thermal dissociation. So a reversible decomposition reaction, a reversible reaction, not normal reversible reaction, but a reversible decomposition reaction occurs by heat only. If we heat, reversible reaction may occur, as at the same time that reaction is decomposition reaction also. So decomposition reaction which is reversible, and this is caused by giving or supplying heat, then such a reaction is called thermal dissociation. Example of thermal dissociation: on heating, nitrogen tetraoxide changes to nitrogen dioxide, a reddish brown gas. On cooling, on heating it will become nitrogen dioxide. On cooling, this nitrogen dioxide again becomes nitrogen tetraoxide. So this is thermal dissociation. Thermal, it is related to heat. Hope all of you have understood today's class. If you like, kindly subscribe, share and give a thumbs up to my channel. Thank you all of you.